Good morning. Welcome to Virtual Solid Edge University. The topic of today's presentation is going to be hidden gems in Solid Edge. We're going to take a look at maybe less known or forgotten things that make you more productive. In particular, we're going to take a look at different options, opening large assemblies. A lot of people concerned about time it takes to open assemblies when a lot of components. We're going to take a look at synchronous technology again, how it helps featurize in non-parametric geometry inside of Solid Edge, especially if that geometry comes from outside the world. We're going to take a look at how we can utilize this new union command that allows for quick and easy FEA analysis on complex assemblies. We're going to take a look at motion, what it brings to the table when it comes to capturing volume of motion, which is very useful. We're going to talk about this a little bit later. And finally, we're going to close with the drafting tips, how you can efficiently work with components lists. So with that, let's begin. The first topic would be assembler preview. You're probably familiar with this function. It's been in Solid Edge since Solid Edge 2022, I believe. So what it allows users to do, it allows for quick review and open large assemblies without spending a lot of time. So while we added in SolidEdge 2023 ability to show hide parts, make some measurements, run reports on assembly. At the same time, this functionality provides a really easy way to access only specific areas of large assemblies and focus on these areas when you need to work on them. And I'm going to show you how it works. The option is available now that you can see clearly where you can edit assembly, and you can edit assembly by opening the whole assembly or with options. And with that, let's dive into Solid Edge and start with demonstration. So we have this Chase Factory, a relatively large assembly. First, I'm gonna open. Actually, let me start the stopwatch, and we're gonna talk about this time that it takes to open this assembly. So there is always option to open as, if you don't want to directly open, if you're in a control how assembly gets open. And if I turn off this option to open assembly preview as for preview large assemblies, and click open, I start my watch, and let's see how much time it takes to open this assembly. By the way, while we're doing that, you can see that system gives you option to stop. If at any point let's say you made a mistake or you want to see only portion of the assembly, you can always click on that stop button, because the system goes through these stages where it loads parts, gives you preview, and at the point where it loads components, you can always stop. So you can see it took us over 20 seconds. Maybe I didn't stop the watch right away, but I know it took about 23 seconds to open this assembly, right? So let's now take a look at what it takes to open with assembly preview turn on. Same workflow. We're gonna open as. This time we're not gonna disable this preview, and when I click open and start stopwatch, that's pretty much it, about 5 seconds. So it's significant gain in performance. So you're not sitting and waiting while assembly opens. And actually you see this clear preview where you can edit this assembly. If you click edit assembly, it will load all the components, and of course you're going to have to sit and wait till all geometry gets loaded in memory. And also we can edit assembly with options. We're going to take a look at this a little bit later, but for now I'm going to show you that we can do assembly statistics on this assembly quite and you can see it's about 8,000 components, 917 unique parts, 1,200 sub-assemblies. All right, and also you will be able to measure. So if we go and let's say measure minimum distance, system warns you that when you're measuring, it's going to be approximate value, but I found it pretty exact. So let's say if I want to measure distance, let's say between this wall and this wall, no problem. Even in preview mode, it will allow me to quickly and efficiently measure. But I want to share with you additional tip. We're talking about hidden gems here. Let me close this assembly again, and I'm going to show you the easy way to focus on a specific area in a large assembly without sacrificing time in order to be able to edit that. So when we go and select all the options we selected before, we can select, as far as configuration, we can select any specific configuration. And if you know configuration which limits number of components, that would be great. Let's say assembly snapshot. It also, because preview is turned on, you can easily open that. It takes no time. And the same way you can see that you can go and measure and do the same thing, assembly statistics like we did with the whole assembly preview. But instead of going and editing assembly, you can go and edit with option and select less saved. What will happen then? It will take only minimum amount of time to activate only parts that displayed on the screen. And in this case, this assembly is ready for editing, even though the whole assembly is not. But this particular one, you can go and edit and place activate and edit those components without sacrificing time to upload it upfront. And of course, if you want to change configuration, you'll pay the full price. You will have to wait till components will load into memory. But this is really quick way to get to specific area and enable it for editing without waiting till the whole assembly will open. So let's move on. The next step would be featurizing non-parametric geometry. This is very useful when you're dealing with geometry, whether it's legacy data or if you brought some data from a different system or via Parasolid, STEP, or whatever, any translation. The bottom line here is SolidEdge provides tools for efficiently identifying and fixing faulty geometry as well, not only quickly featurizing part of your design. We have capabilities to recognize holes, hole patterns, and it helps us control in geometry parametrically for easy editing. So let's go and open this assembly, engine assembly. And one thing I'd like to mention that sometimes when geometry comes from outside, it comes with some faults. And this is the example that we're going to look at here. So I'm going to pick this guy and in place activate. And as you can see, it's a non-parametric body, so there are no features. So this geometry came from outside, maybe from any other vendor or any CAD tool. And you can see it's a quite complex part. So what I want to do, I want to recognize and parameterize all the holes and create hole patterns. For that, I would have to take this body and move it to synchronous. But when I try to do that, it suddenly tells me that there are some faults in this geometry. And it happens a lot, especially as I mentioned, the geometry comes from outside world, from any other system. All right, so we can easily go and run geometry inspector. And when we do that, of course, we found some faults right here. SolidEdge allows quickly and efficiently fix this problem. Let's focus on that. So I can conveniently orient in the top view so I can easily see. And also I want to turn on non-shaded mode so I can see through. So I can see that geometry is actually bigger than originally thought. No problem. I can go and delete faces, selected all the geometry at once. And just simple as that, we were able to fix that situation. Okay, let's go and try to move this to synchronous environment again. Again, it says there is some faulty geometry here. Let's try to analyze it again. Let's go to Geometry Inspector and run it again. And sure enough, we found additional discrepancy. So this counterbore for this hole is too close to the top face, so it creates kind of zero thickness situation. So quite easily we can go and using tools in Solid Edge, again, very efficient, very user-friendly, we can go and offset faces. So I'm going to select this face, offset it, and instead of synchronous offset, I want to define a value and maybe literally minuscule value. So now when we go and try to move it to synchronous, we succeeded. So now we're in synchronous environment and we have access to the tools such as recognize holes pattern. So let's go and recognize hole. You can see how easy it is to do inside of Solid Edge with synchronous technology. I can isolate the holes immediately in the whole body, and I can go and change even properties if I want to do that, change properties on any specific hole. But in this case, I'm going to leave everything as it is, except maybe I can change the order in which the whole thing is sorted, and maybe this center hole, I don't want to convert it, of course, into hole. I'm going to accept, and you can see how system immediately parameterizes all these holes and creates on the fly parametrically controlled holes. So every one of those holes would be editable and parametrically controlled. But I'm going to take it even one step further. I will be able to recognize patterns of all these holes. Select the whole body, and you can see that in this case, Solid Edge gives me access to whatever patterns it found, whether it's circular or rectangular, and I'm okay with that, with all that, and accept the whole thing will get parameterized. Just in 2 clicks, you were able to do that. And now let's see, this bold circle right now for this pattern is 466.72. Let's say I want to make it rounded, let's say 466. I have full control. Right now, just a minute ago, we had this body as a non-parametric design, and now I'm able to parametrically control this design in no time. So this is the power of Solid Edge, fixing the geometry and controlling geometry with synchronous technology. The next step, we're going to take a look at how this new Unite command that is available in Solid Edge 2023 will help us analyze quite complex geometry. And while doing that, we don't have to spend extra time on defining additional geometry when we go through setting up this study. It provides a way to overcome time-consuming process of setting up connectors also, because you'll be able to unite all this in one single body. And also we eliminate extra components that are not required. We're reducing processing time. We get to results quicker. So we're looking at the same assembly. And let me isolate some components on the screen. Let's say we pick this assembly and these 2 assemblies. As you can see, the whole engine is sitting on top of these mount arrangements. And when I go and isolate this information on the screen. So this is the mounting arrangement for this engine. And you can imagine if we want to quickly analyze applying some forces or weight of the engine, we would have to deal with a lot of extra geometry, this engine, because we would need to connect all these parts together. So instead, I'm going to use this union available in Solid Edge 2023. So I'm going to select major component as a tool. I'm going to select all other components. And just like that, in one single operation, I was able to create the assembly feature, union. If you want, you can go and rename it. Let's say engine support. So I'm ready to actually start defining my study parameters. Let's go and create new study. And as you can see, we can define the whole body in one single operation. And what's left to do is just add a couple constraints. And of course, we're going to be supporting this engine from the bottom. So we're going to select a couple faces here and, of course, supporting faces on these two subassemblies. So that's our support. And as far as the load, again, we can create loads on the multiple faces. So I'm going to select this face and couple these faces. So you can imagine the efficiency we are demonstrating here. Instead of trying to define additional geometry, creating connectors. So let's add some weight, so maybe 2,000 pounds, something like that. And that's all there is that's required. We don't need to create any connectors. We just go straight to mesh and solve. And in no time, we'll get results. So imagine, again, the time that you would have to spend adding additional geometry in between all these mounting arrangements and adding connectors. None of that is required. You can get results quickly in no time just by using this unite command that will unite for you even disjointed components in assembly. It provides really efficient and fast way of analyzing your assembly without actually, let's go and animate this. Provides really great way of analyzing your support, in this case, support subassemblies versus trying to create additional connectors, introducing additional geometry, and so on. So this is a great way to quicker results and in the most efficient way. Next up is going to be a little known feature that is available in Motion in Solid Edge. This capability allows us to capture volume of motion. I'm going to show you how it works. It's useful in many situations. For instance, when you're trying to define enclosure boundaries, if you need to define some enclosure boundaries for moving components. It's very useful to define in the volume of a moving component when you're trying to analyze your assembly and see if you're clearing that component during assembly, disassembly. Also, you'll be able to find out how components interact with each other in a complex mechanism. And very important, the motion is available pretty much with every seat of Solid Edge. Okay, let's open this assembly and let's see how motion will help us with this task at hand. So if I go to motion environment, you can see that this mechanism is crank slider mechanism is animated actually. You'll see that it's set up for motion. It animates the way it's supposed to work. And what we can do at this point, we can go and capture interference. We're going to go interference check. And we're going to, under options, we're going to select create parts. And of course, we don't need that many frames, maybe 10 will suffice. And we're going to add components. First of all, we're going to add this cube. And then we're going to add couple moving parts. And we're going to say find. So system will go through this, and you can see on the bottom it calculates number of interferences it found. And of course, the mechanism is moving through every stage as it was set up. So when we go and get out of motion, as you can see now, we created this bunch of bodies that represent. Let me go and isolate this on the screen. So we have a whole set of bodies that represent that volume. So what's left to do is just go into simplify and create the model. And the model will allow us to capture all this information approximately, of course. So we're going to create the extrude. and we define the plane immediately at the center to make sure it's symmetrical. And another trick I would like to share with you, the ability to outline this geometry without touching. If I go and start creating the line as it is, you can see that it gives me all kind of indication and trying to place any constraints. But if I hold down Alt while I'm doing that, it will allow me to go close to the geometry without actually creating any relationship to this geometry. And this way I can go quickly and outline. You can be as precise. This is demonstration, of course, but you can be as precise as you want it to be. And in this case, I'm going to take advantage of relationship assistant. Of course, under options, we don't want any dimensions, but what we want, key point connect. So we can deselect all these, and then it will quickly and efficiently will allow us to connect all the lines in this sketch. And of course, we can select the symmetrical extent, and we go something like this. And what's left to do is create cutout. So we're gonna go and create another feature here. Let's go into unshaded mode so we can see clearly what we're doing here. And the same approach, if I hold Alt, I'm going to create as close as possible the outline of this geometry. And maybe I want to create vertical because this way is the geometry is symmetrical, so we can easily go and mirror all this geometry over this end line and connect with the additional line here. Easy as that. And of course, we're going to use the same relationship assistant just to make sure that we have only key point contact. Select all the geometry, and we are pretty much done. What's left to do, of course, is to define what we're doing. Just by hitting spacebar, you would be doing cutaway, and how far we're gonna go. We're gonna go through all. And here's our volume. Of course, again, as I said, it's approximate volume, but it gives you good idea how the mechanism will move and will give you good idea how you want to clear if you assemble, disassemble the path for a specific part. The last stop would be tables and parts list. We're going to take a look at how you can isolate, or I should say group together um, same kind of parts, whether they were purchased, assembly, manufactured. And with that, let's dive back into Salvage. So we have this juicer assembly, and we're ready to place parts list. Before we actually go and place those lists, let's go into options and let's talk about groups. So what groups allow you to do, they allow you to actually group the similar components together, but this functionality actually relies on custom property that would be placed in every component as part of this. So when we enable these groups, we can go and select what kind of grouping we want. But before we do that, of course, we need to go into columns and define those columns. We're going to pick a couple properties such as manufacturing type. Let's move it up a little bit. And also we're going to pick, let's say, vendor at this column as well. And after we added those columns, then we go into groups and start grouping them. First of all, we're going to select how we're going to group them. We're going to group them by manufacturing type. And first group, we're going to name it as, let's say, assembled. Same for value, and we're going to sort it by manufacturing type. The second group would be machined. And again, the same approach, manufacturing type. And the third group would be purchased. Same idea, we're going to group by manufacturing type. And also what we can do, we can add header to every group if you want to. So for that, let's say we're going to select first group and add, since we want to have separation between groups, we want to add, let's say, 3 rows. And in the middle, we're going to place this first one, which would be assembled, right? So for the machined, the same idea, we're going to add 3 rows. And in the middle, we're going to place machined. And for the purchased, we're going to do the same thing. And we're going to place purchased. So now we're ready to go. And once we accept this, we say OK. And we're ready to place this group in our drawing. And as you can see, it's conveniently grouped in appropriate groups: assembled, machined, purchased. There are more groups that I defined. I can easily go into properties and change the configuration to grouped. And here we go, the whole table is placed with all the components that are grouped by assembled, machined, purchased, and injected and turned. So all these groups are defined. And also I would like to talk while we're here about how easy it is to change the font, the appearance, or change the width of the column. All you have to do is just double click. Maybe you want to make it slightly wider. Also, if you right click in this area, you can highlight components and you can click on thumbnails to show some thumbnails for every item you select. So let's say I want to click on this guy, and it gives me preview of every component, and it also highlighted on the screen. If I go and pick different parts of my design, you can see highlight, you can see preview. This makes it really easy to identify components. But also, let's say if I want to select the whole table, I can easily change instead of dealing with styles, I can easily directly go and change to maybe Arial, right? And the easy is that. Maybe I can change the first row only. Again, double click, select the first row, and make it bold. So this is how easy it is to set up your table components list, and also group similar components by those custom properties. Thank you for your time. If you have any additional questions or would like to leave comments, want to get in contact with me, this is my contact information. Thanks again.